Wakil Pemerhati dari Universiti Malaysia Sarawak, Sekretariat Simposium Kebangsaan Sains Matematik ke-30, para peserta dan seterusnya, tuan-tuan dan puan-puan yang dihormati sekalian. Selamat datang diucapkan ke Majlis Perasmian Simposium Kebangsaan Sains Matematik ke-30. Syukur Alhamdulillah atas limpah kurnia serta rahmatnya, maka dapat kita bersama-sama pada pagi ini, dan pihak majlis merakamkan ucapan sekalung kasih atas komitmen yang diberikan oleh para hadirin dalam menjayakan simposium yang dianjurkan oleh Institut Matematik Kejuruteraan Universiti Malaysia Perlis dengan kerjasama Persatuan Sains Matematik Malaysia dan webinar YTF Siri 24 edisi khas. Yang berbahagia Prof, para hadirin, atur cara majlis akan diteruskan dengan ucapan alu-aluan. Untuk itu, majlis dengan ini menjemput Yang Berusaha Profesor Madya Teknologis Dr. Ahmad Kadri Juno, pengerusi Simposium Kebangsaan Sains Matematik, untuk menyampaikan ucapan alu-aluan. Dipersilakan.
Berbahagia Profesor Dr. Maslina Darus, Presiden Bersama, Yang Berusaha Esko Bersama, Yang berbahagia Profesor Dr. Siti Aisyah Hashim Ali, Fellow Bersama 2019 dan pengucap utama 1 SKSM 30. Yang berusaha Dr. Mas Jamilah Masnan, Pengarah Institut Matematik Kejuruteraan IMK, Universiti Malaysia Perlis, Wakil Pemerhati SKSM 30 dari Universiti Malaysia Sarawak, Sekretariat SKSM 30, para peserta, tuan-tuan dan puan-puan, selamat datang ke Majlis Perasmian Simposium Kebangsaan Sains Matematik ke-30 SKSM 30. Bersyukur kita kehadrat Allah Subhanahu Wa Taala kerana dengan izin dan limpah rahmatnya pada 26 sehingga 27 September 2023 dapatlah kita berhimpun bersama-sama dalam Simposium Kebangsaan Sains Matematik yang ke-30. Pada tahun ini, Institut Matematik Kejuruteraan IMK Universiti Malaysia Perlis telah diberi peluang untuk melaksanakan simposium ini dengan kerjasama Persatuan Sains Matematik atau Bersama dan Yayasan Tuanku Fauziah sebagai penganjur bersama. Tema simposium kali ini adalah Sains Matematik, Pemangkin Kemajuan Teknologi Sejagat. Ia menggambarkan betapa pentingnya bidang sains matematik menjadi pemangkin kepada sesebuah negara dalam kemajuan teknologi serta ekonomi. Saya amat berharap simposium tahunan ini akan menjadi tempat pertemuan dan percambahan idea di kalangan para ahli akademik dan penyelidik, kerana mereka memainkan peranan yang besar dalam memperkasakan bidang sains dan matematik dengan penghasilan penemuan baharu. Hadirin yang dihormati, pihak SKSM 30 telah menerima sebanyak 98 penyertaan dari pelbagai bidang, termasuk sebanyak 89 pembentang kertas penyelidikan yang telah diterima bagi simposium kali ini dan 9 peserta turut hadir. SKSM 30 melibatkan bidang matematik tulen, matematik atau statistik gunaan dan industri, matematik kejuruteraan, pendidikan matematik, matematik pengkomputeran, statistik, pengoptimuman, penyelidikan operasi, matematik dan multimedia, sains aktuari, matematik kewangan, kualiti dan produktiviti serta kecerdasan buatan. Hadirin sekalian, mod pembentangan kertas kerja SKSM 30 diadakan secara hibrid, iaitu melibatkan 55 pembentangan secara bersemuka, manakala sejumlah 31 pembentangan secara dalam talian. Majlis kita pagi ini turut bersiaran secara langsung dalam talian menerusi saluran YouTube Unimap TV. Setinggi penghargaan dan terima kasih saya ucapkan kepada hadirin sekalian dalam menjayakan dan memeriahkan simposium tahunan ini. Selamat bersimposium kepada para ahli akademik, saintis, penyelidik, sarjana penyelidikan dan peserta dari seluruh pelosok negara. Akhir sekali, pihak ahli jawatan kuasa SKSM yang ke-30 ingin memohon maaf atas segala kekurangan dan kesalahan sekiranya ada dalam penganjuran simposium pada kali ini. Sekian, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih diucapkan kepada yang berusaha Profesor Mahdia Teknologis Dr. Ahmad Kadri Juno, pengerusi Simposium Kebangsaan Sains Matematik, atas ucapan alu-aluan yang telah disampaikan sebentar tadi. Malah seterusnya, tuan-tuan dan puan-puan, sama-sama kita saksikan tayangan multimedia yang telah disediakan. Pada demikian, tayangan multimedia khas Simposium Kebangsaan Sains Matematik ke-30. Yang berusaha Prof, sidang hadirin, majlis akan diteruskan dengan ucapan perasmian. Untuk itu, majlis dengan ini mempersilakan yang berusaha pengerusi SKSM 30 untuk mengiringi yang berusaha Profesor Insinyur Dr. Muhammad Syukri Abdul Majid, Timbalan NAB Chancellor Akademik dan Antarabangsa UNIMAP, mewakili yang berbahagia NAB Chancellor UNIMAP untuk menyampaikan ucapan dan seterusnya merasmikan Simposium Kebangsaan Sains Matematik ke-30. Majlis dengan segala hormatnya mempersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi kepada semua. Salam ilmu kelekasan Cemerlangan UNIMAP. Salam Malaysia Madani. Yang berusaha Profesor Madya Teknologi Dr. Ahmad Kadri Juno, pengurusi Simposium Kebangsaan Sains Matematik ke-30 SKSM 30. Yang berusaha Profesor Dr. Maslina Darus, Presiden Persatuan Sains Matematik Malaysia Bersama. Barisan Esko Bersama yang berusaha Dr. Mas Jamilah Mastan, Pengarah Institut Matematik Kejuruteraan Universiti Malaysia Perlis. Yang berbahagia Profesor Dr. Siti Aisyah Hashim Ali, Pengurus Besar Pengalaman Pelajar dan Teknologi Open University Malaysia Selangor selaku pengucap utama pada SKSM 30 hari ini. Wakil Pemerhati SKSM 30 dari Universiti Malaysia Sarawak UNIMAS. Para penaja, peserta SKSM 30 dan seterusnya sidang hadirin saya hormati sekalian. Alhamdulillah, marilah kita bersama-sama melahirkan rasa syukur kehadrat Allah Subhanahu Wa Taala kerana dengan limpah kurnianya dapat kita bersama mengizinkan untuk bersama-sama dalam majlis Perasmian Simposium Kebangsaan Sains Malaysia SKSM yang ke-30. Tahniah dan syabas saya ucapkan kepada semua dan kepada Institut Matematik Kejuruteraan dengan kerjasama Persatuan Sains Matematik Malaysia Bersama dan webinar Yayasan Tunku Fauziah YTF siri ke-24 edisi khas yang saya fikir telah bertungkus lumus dalam menjayakan penganjuran simposium peringkat kebangsaan ini. Hadirin yang saya hormati sekalian, Institut Matematik Kejuruteraan atau IMK yang dikenali sebagai IMK merupakan pemain utama di UNIMAP dalam menyediakan perkhidmatan pengajaran serta mempunyai kepakaran pendidikan yang tinggi dalam 6 bidang tujahan utama, iaitu matematik kejuruteraan, matematik gunaan, pendidikan operasi, teori fizik, statistik dan juga matematik tulen. UNIMAP amat berbesar hati sebagai tuan rumah terhadap penganjuran simposium kebangsaan ini yang menjadi satu acara tahunan menghimpunkan semua cendekiawan sains dan matematik dari dalam dan luar negara bagi membentangkan hasil penyelidikan terkini, penyatuan penyelidik tersohor dengan penyelidik baharu dalam pelbagai skop sains dan matematik melalui bumbung SKSM yang ke-30 ini diharap dapat merancakkan budaya pengkongsian ilmu serta penyelidikan dan sumbangan terkini dalam bidang sains dan matematik. Ilmu sains dan matematik memainkan peranan yang sangat penting dalam pelbagai cabang ilmu yang lain seperti kita sedia maklum, kejuruteraan, teknologi, keusahawanan dan sebagainya. Justru itu besarlah harapan saya agar sains dan matematik serta aplikasinya dapat dibincangkan secara ilmiah serta kreatif dan melahirkan idea-idea inovatif dalam kalangan ahli akademik, para saintis dan pakar-pakar bidang serta pakar daripada industri dan penyelidik di dalam dan luar negara. Hadirin yang saya kasihi sekalian, sebelum ini Menteri Pendidikan Tinggi Datuk Seri Muhammad Khalid Nordin dalam ucapannya telah menyampaikan panduan yang amat jelas tentang hala tuju penyelidikan negara untuk beberapa tahun akan datang dalam 5 prinsip penting. Beliau memberikan penekanan kepada kepentingan penyelidikan sebagai pencetus kepada ilmu baharu dan seterusnya memberi manfaat yang besar kepada negara. Tidak dilupakan kepentingan kerjasama strategik dalam usaha mendanai penyelidikan dan pelaksanaan penyelidikan jangka panjang yang melibatkan konsortium penyelidik dalam pelbagai disiplin. Beliau menggariskan kepentingan melaksanakan penyelidikan berlandaskan etika, proses yang sihat dan prinsip profesionalisme. Malah dalam aspek kewangan, penyelidikan mampu menjadi punca pendapatan kepada universiti. Sebagai sebuah universiti teknikal dalam rangkaian MTUN, UNIMAP menyokong kesemua 5 prinsip panduan yang telah digariskan oleh YBM Datuk Seri Muhammad Khalid Nordin tersebut. Kemajuan negara juga dapat disokong melalui aktiviti penyelidikan dan pembangunan inovasi dalam bidang sains dan matematik, dan diharapkan dapat membantu pihak industri meneroka pelbagai hasil penyelidikan dan inovasi yang berpotensi dan seterusnya merevolusikan industri mereka. Saya percaya melalui penganjuran SKSM ke-30 ini, penemuan ilmu baharu dalam sains dan matematik mampu melahirkan sistem serta inovasi-inovasi penyelidikan yang punya nilai komersialan. Ia amat bersesuaian dengan tema SKSM, iaitu Sains Matematik Pemangkin Kemajuan Teknologi Sejagat. Besarlah harapan saya agar penganjuran SKSM kali ini berjaya mempromosikan disiplin sains dan matematik sebagai satu profession dalam komuniti yang luas, terutamanya kepada pembuat keputusan dan aplikasi dalam kejuruteraan dan industri. Hadirin yang dikasihi sekalian, sebelum mengakhiri ucapan pagi ini, izinkan saya sekali lagi untuk mengucapkan ribuan tahniah dan syabas kepada semua jatuhankuasa penganjur, penaja-penaja, para penyelidik dan semua pihak yang terlibat secara langsung atau tidak langsung dalam menjayakan SKSM yang ke-30. Dengan lafaz Bismillahirrahmanirrahim, saya dengan ini merasmikan Majlis Perasmian Simposium Kebangsaan Sains Matematik yang ke-30. Sekian, wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih Prof, dan mohon yang berusaha Prof untuk terus kekal di pentas bagi atur cara berikutnya. Para tuan-tuan dan puan-puan, majlis akan diteruskan dengan gimmick perasmian yang akan disempurnakan oleh yang berusaha Profesor Timbalan Naib Chancellor Akademi dan Antarabangsa mewakili yang berbahagia Naib Chancellor UNIMAP. Sama-sama kita saksikan di pentas utama. Baiklah, dengan ini rasmilah Simposium Kebangsaan Sains Matematik ke-30 bertemakan Sains Matematik Pemangkin Kemajuan Teknologi Sejagat. Terima kasih diucapkan kepada yang berusaha Prof atas gimmick perasmian sebentar tadi. Yang berbahagia Prof, sidang hadirin, majlis akan diteruskan dengan ucap tama 1. Jadi sebelum menjemput penceramah utama, izinkan saya membacakan serba sedikit latar belakang beliau. Profesor Dr. Siti Aisyah Hashim Ali adalah profesor dalam bidang matematik gunaan dan pendaftar di Universiti Terbuka Malaysia, OUM. Beliau menumpukan aktiviti pengajaran dan pembelajaran dalam Open and Distance Learning ODL dan Teknologi Pembelajaran. Dengan kerjasama antara ahli akademik dan eksekutif, beliau sentiasa berusaha ke arah pembaikan dan kepatuhan dalam aspek pengajaran digital dan pembelajaran dalam platform ODL seperti bahan pengajaran dan sokongan teknologi. Selain daripada kerjaya akademiknya, Profesor Siti Aisyah juga sering menyumbangkan kepakaran kepada masyarakat melalui beberapa pertubuhan, iaitu Persatuan Alumni Program Persahabatan ASEAN Jepun Abad ke-21 Malaysia atau PAMAJA dan Alumni Sekolah Sains Kedah ASSAK. Beliau juga adalah salah seorang fellow bagi Persatuan Matematik Malaysia dan telah menerima pelbagai anugerah dan pengiktirafan atas sumbangan dan perkhidmatan sosial yang telah dijayakan. Hadirin sekalian, tanpa melengahkan masa, majlis mempersilakan yang berusaha Profesor Dr. Siti Aisyah Hashim Ali, pendaftar Universiti Terbuka Malaysia, untuk menyampaikan ucap tama bertajuk Matematik, the foundation of science and technology. Dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. Very good morning ladies and gentlemen. Yang bahagia Profesor Insinyur Dr. Muhammad Syukri Abdul Majid, Timbalan Naib Chancellor Akademik dan Antarabangsa UNIMAP, Yang Berusaha Profesor Madya Teknologis Dr. Ahmad Kadri Juno, which I'm proud to announce that he was my student way back in 1996 and 97 under special selected student, student yang cerdik-cerdik selected under rancangan persediaan khas Jepun. Okay, very specialized, selected group of students. We only took about 100 a year to send to Japan. So he was the selected one. So I'm very proud to meet him today. Okay, Profesor Dr. Maslina Darus, Presiden Bersama, Yang Berusaha Profesor Dr. Mas Jamilah Masnan, Pengarah Institut Matematik Kejuruteraan UNIMAP, Exco Bersama yang hadir, rakan-rakan Exco Bersama yang saya hormati, Sekretariat SKSM 30 yang saya rasa telah beberapa bulan bertungkus lumus untuk menjayakan simposium ini, hadirin hadirat yang saya hormati. Yang bagi Prof, saya mohon izin untuk menyampaikan ucap utama saya dalam bahasa Inggeris kerana menghormati rakan. Saya rasa saya nampak ada beberapa rakan-rakan daripada luar negara. Okay, thank you very much. Okay, I'm first of all, let me thank you. I would like to thank Bersama, and I would like to thank Institut Mathematics Kejuruteraan UNIMAP and the Secretariat of SKSM 30 for the honor given to me to deliver this speech. I was in a way a bit worried because the title, the title was quite general looking at it. So I decided, though my area of research is mathematical modeling in the electrochemical system, mostly in the lithium-ion battery system. But I think this time I would like to talk something more general to the mathematics audience because I'm not the expert in every area there is in mathematics. So can I have the presentation, please? Okay. So what I'm going to talk is about, we are mathematicians. So of course we have to agree that mathematics is the language of science and technology. Let me move a bit. Okay. All right, so that's the title of my talk today. Okay. Okay, so this is called a book of nature, which is written in the language of mathematics. So it was written by Galileo Galilei. We all know him. So at that time, people are looking for what are the best language to describe science and nature. Okay. Okay. So mathematics is accepted as the instrument to comprehending the intricacies and working of our surrounding. It became what we call today the language of science and technology that is spoken and understood universally, thus empowering us to scrutinize, articulate, and predict the working of nature. So I think most of us from at a young age, we were introduced to the concept of arithmetic and then mathematics. And I'm sure most of us here, why we study mathematics, for me, why I took on into mathematics, because I get bored when I read books like biology, but I find numbers are so interesting to me. Yeah, I always call my biology book is my sleeping book. Whenever I read my biology book, I can fall asleep within 15 minutes. Okay. So those yang malas baca buku lah, orang Kedah kata malas baca buku, kita buat matematik. Yang baca buku, they go and become doctors, lawyers and things like that. Those who malas baca buku, you become, who likes numbers become mathematician, engineers, technologies, and that's what UNIMAP is all about. It's about having mathematician, engineers, technologists, data scientists, and I think I'm with the right crowd this morning. Yeah. So just to recap on the topic, science and technology. So what is science? Science is a systematic study, of nature, of natural world, through observation and experiment. We conduct experiment, we do observation of nature, and then but you have to do it systematically. It's not just a one-off observation or one-off experiment, and then you look into the principle behind that experiment, behind that result, behind that occurrences in the nature. So that is all about science. Yeah, and then point number 4, science is a self-correcting process. I believe science is a self-correcting. Science is not a stagnant process, and that continually advances our understanding of the world around us. Okay, and okay, so what's technology now? Technology refers to the application of that scientific knowledge. Yeah, it's tool and techniques to create practical solution, improve processes, and achieve specific goals in various fields. So, in other words, I would say technology is the application of science. Yeah? So I think we go through. So, so there's a need for a language, right? There's a need for a language. All this we need to document it systematically. We can't just put it in any language, because as you know, various countries, various culture has different language. And it needs to be documented. So we need a language that precisely communicate that scientific idea. Okay, so that's when people start looking for what language to use. Nak pakai bahasa Kedah ke, pakai bahasa Kelantan ke, or whether that's compatible or not. Alright. So the problem with natural language, many scientists or people way back before our generation having problem with the natural language. So for example, our standard one is English or Malay. So we have to agree, that's not suited. In Kedah, segan means malu. Yeah, you are shy, segan. But in KL, segan means malas. I'm lazy. So that's only one of the meaning, right? So there are often many natural language, most often imprecise, ambiguous, and limited to their ability, right? Okay. So natural languages are subject to regional variance, cultural influence, and can further complicate the communication and lead to misunderstanding. Okay, so one example, I put one example, the word lead. When I browse through, there's 8 meaning for the word lead. Yeah, from leading an organization, be on the lead, our pencil lead, yeah, the black thingy thing inside, yeah, poisonous, poisonous soft metal inside our pencil is also called lead, right? Direction, leading a direction. So one word, yeah, 8 different situation. Okay. Okay, another one. Oh, sorry, skip one. Okay. Oh, okay. Mandarin. Anybody speaking Mandarin here? Any Mandarin speaker? No, we don't have Mandarin speaker. Okay, this is what I can find. So we are used. The one that I'm used to is like ni hao ma. So ni hao ma. How could be how Are you okay? Ni hao ma, are you okay? So could be good, could be well, could be easy. How, okay? And fond of. And then jiao, small, little, young, many meaning, yeah, da. I mean, if in Malay or like English sometimes, da means you stupid or what, da. So can mean that, right? Okay, so you see, this is some of the reason why natural languages are not precise for describing scientific knowledge, right? So, okay, there. I remember those students who are in previous, when I was teaching in Pusat Asasi Sains University Melaya. One of the topic that I enjoyed teaching is called mathematical logic, class logic, yeah. So because I get to play with the students on all this. So for example, this is a natural language, English. So this gentleman tell a butler, James, please call me a taxi. And then the butler goes, being an honest butler, very direct call, yes, Mr. Taxi, right? So that's ambiguity that the language can create. So same thing when I was teaching my students, I would say, define perbezaannya. Jika ayam jantan, maka ia berkokok. Jika ia berkokok, maka ia ayam jantan. So which is the true statement? Alright. So those are the things with language. You get to play around, and it can be double meaning, triple meaning. Okay, so that's it. So now let's focus on mathematics, the topic of today, that we want mathematics to be the language of science and technology. So why? Why? Being a mathematician, I think we agreed that the language of science must be precise, right? Precise. Describe exactly what it means. No double meaning, unambiguous, and able to express complex concept. That's the most important, to express complex concept. Okay? And then handling things that are abstract and make generalization, and then must be universal enough. Yeah? Once we learn the language, we learn mathematics is a universal language. For us, some of the symbol is a universal language, right? What does it mean by delta? What does it mean by the little delta that we use as differentiation? So you learn the language and it's universal. You doesn't have to speak that language, but you can understand, and adaptable. Okay? So having said that, let me try and, so years over development, civilization, it has been said that mathematics fulfill the requirement to be the language of science, right? It's powerful for scientific inquiry, discovery, advancement of knowledge in various scientific disciplines. So I would like to show you this one, what I mean, the language, yeah? So example of a precise and unambiguous mathematical statement. We all know this. I think Prof. Haniza teaching algebra would know this. We always start with, for all real number, yeah, x and y, if x is greater than y, then the square of x is greater than the square of y. I remember being an undergraduate, if you're asked to prove that simple statement, and then you go like, of course it's a real number, right? So this simple statement can be proved, right? But the beauty, the last line there, the beauty of the mathematics language, notation, it can be written in a simple, and you can read that, yeah? You can read for all x and y that belongs to the set of R, real number, yeah? Then, right, y equals to x squared implies that x squared is greater than y squared, right? So that's universal. That's my point of having said that Mathematics is the universal language for science and technology. It's very precise. You can't deny about it. People cannot twist your words about it. Kalau orang Kedah kata, hang kata apa, kata lain macam ni, no. Mathematics does not apply to that. It's very precise, right? So maybe in politics they should use more mathematical statement so that it become more precise, and then we get to understand people like us. Yeah. And this kind of statement applies to all branches of mathematics. So today, in this hall, I'm honored to be speaking to many fellow mathematicians. Some of them are my students. I have one my ex-master student with me also today, so I'm very honored that she can make her time to be with me today. So you'll see that we spread around in the universe. Yeah, we studied calculus, we studied algebra, abstract algebra, linear algebra, real analysis, probability, topology. Not that something that I like, topology. Okay, and then sequence, series, combinatorics. The combinatorics are more for people in the computer-related subject, right? Combinatorics, and then you have set theory, graph theory. So there's various, and all of us, I name a few, but all of us, we managed to communicate to each other using the mathematical language. Okay, that's the beauty of mathematics, right? So as I mentioned just now, mathematics has allowed us, scientists, we can call ourselves scientists, or we can call ourselves mathematicians, to express and communicate ideas and information precisely, precise communication, make prediction, test theories, and uncover hidden patterns and relationship in data. So my next few examples, I will share some of the big discoveries that sometimes we didn't realize, but how we uncover patterns, relationship in data. All right, so let me try and get examples, yeah? Since I did a lot of work in mathematical modeling from something in nature. I did modeling in a fractal. Did also a bit of modeling in soliton, solitary wave, and then finally modeling in battery system. Yeah, that time the handphone battery are quite new in year 2000, right? You remember carrying your big phone with nickel metal hydride battery, and then slowly it progressed to what we have, lithium ion now. Okay. So I'm sharing half of my talk with what are the achievements that people, scientists and mathematicians help to contribute to the world, and also help to destroy the world. Okay, so let's see this. Okay, let's start with something big, the formation of the universe. Okay, the formation of the universe, what we call the Big Bang theory. Okay. So the next video will show you the result of Illustris project. It's a project which is a large cosmological simulation of galaxy formation. Finally, managed to be completed, I think, in the year of 2013. A complete formation of the universe. The simulation followed 12 billion resolution elements. The bonding, the breaking and rebonding, okay, spanning a cube of 35 million light years on a side, and evolved over 13 billion years. So this is a long period of running programming. The program, it took, the astronomer dedicated 5 years to programming. And then it took 8,000 CPUs running in unison. Yeah, 8,000 CPU run together for about 3 months to crunch all the numbers and the model based on. which if you use a normal desktop, our normal average desktop, it would take 2,000 years to complete. So let's see how, okay? Okay, this is so you will see that the timing, 0.6 billion years, 0.7 billion years, the forming. So this has never been done. You will see how the molecules, the ion started to form, and then you will see a bit of bang. There's the breakout. Yeah, okay. So mathematics helps scientists to form all this. Yeah, when I first discovered this simulation, I was quite excited that finally it can be done. So the simulation, there's this 360 degrees rotation of the program. So it runs. So you can see the rate, the power after the banging of the atoms. So you have 4.5 billion years, yeah? About 5 billion years ago. Ni nampak tak? Cukup terang tak? Tak nampak? Maybe light, a bit kill light kiri kanan boleh? Bagi terang sikit. Can we kill the light? Start balik, nak tengok balik Big Bang Theory. Alamak, sekejap. Let me see whether I can start. Okay, start balik Interesting. Sebab kita, we dream about this, but we never thought we can be done. Alamak, saya tak start. Next, I tekan next. Okay. Right. Let's enjoy completed in 2013. Baru completed the whole simulation. So the beauty is that seolah-olah there's a photographer framing it, right? The simulation rotate at 360 degrees angle. Before this memang tak boleh buat lah, kan? Computing power kita tak cukup. But now it can be done. So after this, scientists, technologists from UNIMAP can also develop something great as that, kan? The body of language, body of knowledge. So from the gases now, there's a lot more heavy elements being formed. The gases tu dah mula form, and then later that's how stars, planets, can form after all this had happened. Okay, next, something smaller. From the universe, let's go to the bacteria, because we have just passed through one of the, what I call, I told my children, one of the lifetime experience. Who would thought that we live in a generation that go through 2 years of lockdown? So as an undergraduate student, I did study what they call mathematical biology. So this is it, bacteria division, right? So it started from that simple equation, y equals ab to the power of x. Yeah, where y is the final amount. Yeah, and we started and said this is division of two pairs of bacteria. Yeah, and then it expand. The breaking because the breaking of it cause the expansion, right? So that's the expansion of bacteria. Okay. So a lot of project, yeah, Prof. Boleh apply banyak project ni untuk FRGS ke research on all this simulation modeling. The beauty of doing modeling is you don't have to have a proper lab. You model just with your computers. Okay. So and another slightly smaller than the bacteria, which is the interaction of water molecules. Okay. Water molecules are polar. Yeah. Meaning they have the positive and the negative end. So this polarity allows water molecules to form hydrogen bonds with each other. So in liquid, hydrogen bonds are constantly formed and broken. That's allowed the character of the fluid that we have, the fluid dynamic. So and the energy that is applied and keep inside them cause them to broken and forming, and if the heat is strong enough, it will escape kan, and then dia jadi gases kan. Kalau we are boiling water, it will escape, it becomes steam. So that's the formation of the water molecules. Okay. Okay, next. Okay, what I call useful maths. Engineering people like useful maths. Okay. Okay, the famous Navier-Stokes equation. Okay. Okay, one line. The famous. We have mass conservation, viscous, drag, convection, gravity. Okay. This equation, as I stated that, describe completely the motion of a fluid at any point within the flow at any instant point. Okay. The real problem kena solve numerically. You cannot solve analytically. Okay. But it has been used, powerful equation has been used in ocean wave. And then so I'll show you the example. Okay. Okay. Prior to good computers capacity, so people have wind tunnels. I think UTM has a good wind tunnel lab. UTM, am I right? You have a wind tunnel lab, and most universities have a wind tunnel lab to do all this simulation. But now it can be done using the power of computing. So this is the angle, the angle of attack of the wind through any. Sometimes you use this for the wing of your airplanes, for example, right? So I used to have one final year project when I was in my final year. Calculate the rotation and the lift of the helicopter, right? Blade. So these are the things that can be done from Navier-Stokes equation. Another one is Typhoon Mawar. It happened. It's a very powerful typhoon. Happened in August 2005. Yeah, and then it moves and reach the intensity peak started in August. Intensity peak on September the 2nd, and it reaches 185 kilometer per hour. So if we try to calculate, it's quite impossible, but it can be simulated. And then by September 4th, it reaches Japan, and we see in the news the damage that it caused. So this simulation shows the progress of the Typhoon Mawar in 48 hours. What really happened during that 48 hours? Okay, what they call it, using the weather research and forecasting model. They have the model now. The model has 3.3 kilometer grid point. Okay, so next, okay, this I think what I call the destruction part. Okay, next. Anybody remember this? Remember this? The famous Indonesian tsunami. I saw some delegates, some friends from Indonesia. Correct, we have 2 friends from Indonesia, right? Yeah. So this is the Indonesian tsunami and we are all devastated. And we, most of us here being from the northern region of Malaysia, you can see how this tsunami, it started with an earthquake, right? Earthquake on December 26, right? The earthquake, I think about 9.1 to 9.3 scala, right? So you can see it started that earthquake and then how the wave goes through. This is completed one. I've seen a few under certain country, but this is, so that's why you see that the northern part of Malaysia, yeah, Kedah, Penang, yeah, some part of it experience the wave, right? So the progress, this is done under by the what do you call, Cornell Multi-Grid Couple Tsunami, COMCOT. The simulation was done by Cornell University, right? That's tsunami. Okay, next. Okay, enough distraction for now. We take a break and see something beautiful. What I call pretty maths. I did a bit of study on fractal, where a student of mine developed, because that study of fractal for my group, it happens quite an accident. We were developing thin film for battery, lithium ion battery. We were mixing and trying to do thin film so that we can produce our own battery. We want to fold the battery, so we have to do it in thin film so that we have a bigger surface area for the ion. And then some that didn't come out nicely, we just leave it on the table. And a few months later, we find something growth on it. So the growth pattern is quite pretty, so we discovered it was actually a fractal. So and then later we tried and we see that different concentration of chemical produce different pattern of the fractal pattern, and we managed to calculate the dimension. So that becomes later a master thesis by accident. Yeah. So this is pretty nice. I'm showing you the most famous, the Mandelbrot set. Simple equation, Zn plus 1 is equals to Zn to the power of 2 plus C. Simple basic equation, but the result is Mandelbrot set. And the beauty of fractal is it keep on duplicating itself at every step, every level. Self-repeating pattern. So we are zooming in. Macam kita photostat, kita enlarge, photostat, enlarge, photostat, enlarge. Is zooming in, and you see the pattern is self-repeating. That is the beauty of fractals. So if you want to study fractals, you can also do a study for security. There's using fractal to simulate the crack inside your the eyes. For security reason. You can also do fractals of nature, looking into the branching of rivers, that's fractal. The formation of the coastal line, that's also fractal. The fern leaf, that's also fractals. Okay, so this is something I get from the internet, from a research done. They did the simulation and they zoom in and zoom in and zoom in. And it was pretty, okay? Okay, we can ask our maybe final year student as a project to write a program that reproduce some fractal formation. Okay, almost done. Okay. Okay. So after that break, so a bit of scary. This is something I would say that is close to my heart because in 1995, remember when they mentioned that one of the NGO that I was involved is what we call Friendship Mission for the 21st Century. So that was a scholarship given by JICA to go and visit Japan and spend a month with their school children to educate them of the impact of World War II. Okay, because my mother, my grandparents and my mother lived through that World War period in Kedah, so I've heard many stories about what happened in 1944, 1945. So I took up that scholarship, and the basic of that, yeah, of course you know the bombing. I mean, let me just go back. Oh, okay, E equals to MC square, right? E equals to MC square. Most famous equation. I don't have to introduce who that gentleman to you. Everybody knows him, right? So he formed that in his theory of relativity. So a simple total energy, yeah, total energy release E, yeah, of an object is proportion equal to the mass. So little mass, but because the C is light of speed, so when you square the light of speed, kan, besar kan? So you square it and you multiply to the mass, so you get big effect. Okay, okay. Let me see the effect. So this is a footage of in 1958. The camera is on board of a ship 5.4 kilometer away. The bomb is placed underground 150 meter. So So the video shows an underwater test explosion of a nuclear bomb. The blast occurred 150 meters underwater and created a spray dome that reaches a height of 840 feet. After 7 seconds, it reaches 840 feet. After 20 seconds, it has a diameter of 3,800 feet diameter. Okay, so this is scary maths to me, right? A simple equation E equals to mc squared, thus that. So you can see the birds are actually not at the ocean, is nearer to the boat, okay? The on ship boat, the ship. So that's how you can see the bird. So that's the what math does also. Okay. Okay. I'm almost to the end of my presentation. Let me try and get the next slide. Mission that took 3 days. Massive energy, right? They have to bring a lot of fuel. But recently, the Indian group, yeah, has launched, and it has successfully landed recently the Chandrayaan-3. Chandrayaan-3 took 40 days to reach the moon, compared to NASA 3 days. Okay, but less fuel power. So the beauty of it, I want to show, is the calculation involved, the exact calculation involved by the scientists. Okay, this is Apollo. Okay, you can see from the blue, don't know. Okay, that blue thingy. Okay, this is the route of the Apollo. It goes and it lands. So a lot of power to push the space shuttle out of the orbit, and then later a lot of power to stop it to land. And then the same thing, it goes home and landed. Okay, so this is Apollo. This is Mak Saleh. Okay, so let's see what Asian can do. Okay. Oops. Tak ada, terpecah termelang pula. Okay. Chandrayaan 3. Okay. This is Chandrayaan 3. Okay. No. Where does it? Tak nak. Siapa jaga slide tak? Ada. Doesn't go back. Huh? Ouch. Boleh manual tak? Tak boleh, slide tu. Go back one dekat Chandrayaan 3. I want to show Chandrayaan 3 ni because tak dapat. Kenapa dia kalau dia? Oh no. Oh no. Yeah. You control lagi kejap. I think not working. Sorry, but I tell the story first. Okay, the Indian Space Research Center launched Chandrayaan 3 on July 14, 2023, recently, about 2 months ago, from Sri Harikota Secondary Pad. Okay, the spacecraft was carried and put into orbit. Okay, put into orbit. The first one in July 15. And they have July 17, the second one July 22 and July 25. Okay, then the trick is to have okay, that's it. Okay, to have that space shuttle to have that space shuttle circles the Earth, eventually going, you can see the eclipse going and going until it has gained enough energy to shoot off to the moon. So very little fuel needed. And then later upon landing, it goes, repeat the same circle and come back. So that cost 40 days, but it has landed, touchdown again on August 23 at 5:47 p.m. Indian Standard Time. So it has been successful. When I was asked by the secretary to give this talk, I started researching on this topic. It was still in orbit, so it has landed, Alhamdulillah. So that was to me a good success story of how precise mathematics has helped many scientists, technologists to simulate, to study, and finally put that into practical uses. Okay, I'm not sure whether, if the slide has failed on me, so tak ada habis never mind. I was trying to show you the beauty. I want to give you a heart. You saw a bit just now. Okay, so it was a heart of how I love all of you. Thank you for listening to me. It is an honor to be here and once in a lifetime. Thank you so much and Assalamualaikum warahmatullahi taala wabarakatuh. Thank you, Nadia.
Terima kasih diucapkan kepada Yang Berusaha Prof dan mohon untuk terus kekal di pentas bagi atur cara yang berikutnya. Baiklah para hadirin, majlis akan diteruskan dengan penyampaian cenderahati. Untuk itu majlis dengan ini mempersilakan yang berusaha pengerusi SKSM ke-30 sekali lagi untuk mengiringi yang berusaha Timbalan Naib Chancellor Akademik dan Antarabangsa UNIMAP mewakili yang berbahagia Naib Chancellor UNIMAP untuk penyampaian cenderahati. Dipersilakan. Baiklah, majlis akan dimulakan dengan sesi penyampaian cenderahati kepada yang berusaha Profesor Dr. Siti Aisyah Hashim Ali. Kita berikan tepukan kepada pengucap utama 1 SKSM 30. Terima kasih atas perkongsian yang diberikan. Dan majlis akan diteruskan dengan penyampaian cenderahati berikutnya. Untuk itu dipersilakan yang berusaha pengurusi SKSM 30 untuk menyampaikan cenderahati kepada yang berusaha Profesor Insinyur Dr. Muhammad Syukri Abdul Majid, Timbalan Naib Chancellor Akademik dan Antarabangsa UNIMAP mewakili yang berbahagia Naib Chancellor UNIMAP. Terima kasih diucapkan kepada yang berusaha Prof atas kesediaan bersama dengan kami merasmikan majlis pada hari ini. Baiklah yang berusaha Prof, para hadirin, dengan berakhirnya sesi penyampaian cenderahati sebentar tadi, maka Majlis Perasmian Simposium Kebangsaan Sains Matematik ke-30 tiba ke penghujungnya. Majlis sekali lagi merakamkan ucapan jutaan terima kasih kepada yang berusaha Timbalan Naib Chancellor Akademik dan Antarabangsa UNIMAP mewakili yang berbahagia Naib Chancellor UNIMAP atas kesediaan merasmikan majlis pada hari ini. Terima kasih kepada barisan jawatankuasa dan semua yang terlibat dalam menjayakan SKSM 30. Kita berikan tepukan sekali lagi. Baiklah sidang hadirin dimohon untuk berdiri bagi nyanyian lagu Semangat UNIMAP dan akhir kata dari saya dengan kalimah mulia wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih semua. Baiklah, terima kasih semua. Itu